Hi, in this video, I will be showing you problem number 45 of chapter 14, section 1. Draw a contour map of the function showing several level curves f of xy equal to x square minus y square. So first, what is the concept of, what do you mean by level curve and contour map? The contour map is actually the projection of the level curves of the surface on the xy plane. So what are level curves? The level curves are curves of intersections of the surface with the horizontal plane z equal to k. The level curves are curves at different heights of the surface as well, right? They are f of xy equal to k, or you are setting z equal to k for various values of k. So let's give a specific value for k. Z equal to f of xy equal to k. Let's assume k equal to 0, which means you are pretty much taking the xy trace. So if you substitute that back into the original equation given in the problem, z equal to k equal to 0, x square minus y square equal to 0, that will be x equal to plus or minus y. So which are two intersecting lines passing through the origin. Next, let's assume k equal to 1. If you substitute that back into the original equation, x square minus y square equal to 1, which is a hyperbola, as coefficient of x square is positive, the branches cross the x-axis at plus 1 and negative 1. If you bring it to the standard form, x square over 1 minus y square over 1 equal to 1. So x-intercepts are at plus 1 and negative 1. So the graph, the trace, xy trace is going to look like this. Let's give one more value for k. Let's assume k equal to 4, which is positive. X square minus y square equal to 4. If you bring it to the standard form again, x square over 4 minus y square over 4 equal to 1, which is a hyperbola intersecting the branches intersecting the x-axis at 2 and negative 2. So for all positive values of k, you're going to get hyperbolas intersecting the x-axis. So we have shown two examples here. K equal to 0 case and k equal to 1 and k equal to 2 as k equal to 4. The three cases shown here for xy trace. Now if we take k to be negative, see all the values that we showed before are k equal to either 0 or positive. So what happens when k takes up a negative value? The level curves of the surface for k more than or equal to 0 or k more than 0 are hyperbolas where the branches cross the x-axis. But if k was equal to 0, we know that it should be two intersecting lines passing through the origin. Let k be less than 0, say k equal to negative 1. Substituting that back into the original, you get x square minus y square equal to negative 1. So y square minus x square equal to positive 1. So if we bring it to the standard form, you get y square over 1 minus x square over 1 equal to 1, which is a hyperbola where the branches cross the y-axis at plus 1 and negative 1. A rough sketch is shown like this. Now let's assume k to be equal to negative 4. So x square minus y square equal to negative 4, which can be written as y square minus x square equal to positive 4. Again, bringing to the standard form, you get y square over 4 minus x square over 4 equal to 1, which is again a hyperbola intersecting the y-axis at plus 2 and negative 2. A rough sketch of that is shown here, crossing the y-axis at 2 and negative 2. For all k less than 0, we get a family of hyperbolas. The level curves are family of hyperbolas with the branches crossing the y-axis. So in summary, we can say when k equal to 0, the level curves are two intersecting lines passing through the origin, and when k positive, the level curves are families of hyperbolas where the branches cross the x-axis. When k is less than 0, the level curves are hyperbolas where the branches cross the y-axis. Intersecting the y-axis. We can, the contour map is shown below, which are projections of the level curves on the xy plane. So that is what we are going to show here. So we get two intersecting lines corresponding to k equal to 0. They pass through the origin. One is y equal to x, the other one is y equal to negative x. Then we will graph the contours for k more than 0. So when k equal to 1, you get hyperbolas crossing the x-axis at 1 and negative 1. When k equal to 2, the branches cross the x-axis at square root of 2 and negative square root of 2. So this is a hyperbola corresponding to k equal to 2, positive 2. The two branches should correspond to k equal to 2. Same way, k equal to 3, the hyperbolas will cross the x-axis at square root of 3 and negative square root of 3. Then we can also give similarly values for k less than 0. When k is less than 0, you get hyperbolas intersecting the y-axis at k equal to plus 1 and k equal to y equal to plus 1 and negative 1 for k equal to negative 1. And for k equal to negative 2, again, the branches of the hyperbola cross the y-axis at square root of 2 and negative square root of 2, y-axis at square root of 2 and negative square root of 2. So k equal to negative 3 will be hyperbolas crossing the y-axis at square root of 3 and negative square root of 3. So when you do the contour maps, then they should be equally spaced. So you have to have the step values, which are the k values which are equidistant. Hope this video helps.